Okay, for subspace is similar to you have learned by drawing the Venn diagram, right? You have a set, and then a part of the set is the subset. So same goes with the subspace, where you have a vector space. Let's say you have a vector space W, and then suppose S is a non-empty subset. So S is a part of vector space V. So the theorem for subspace is that, okay, if let's say S is a non-empty subset of a vector space V, then S is a subspace of V if S satisfies the following two conditions. So means that if let's say the question is you have to determine whether it is a subspace or not, so you have to fulfill these two conditions. The first condition is vector addition, where if let's say you have a two vector as an element of S, then the addition vector is also an element of S. Okay, and then the second condition is scalar multiplication, where you have alpha u. Okay, when your vector u is an element in S, then alpha u is also an element of S. Okay, question number 1. Determine whether the set S is a subspace of R2. Okay, this is the vector space R2. Why it is 2? Because you have two components here. Okay, if let's say R3, then you have three components. Okay, so first, because the first condition is you have two vector is an element of S. So since you cannot see any vector here, so you have to let first. Okay, you have to let a vector V and S, where this V and S is an element, is a R2 in a vector space 2. If let's say you have AB, so you can use AB, CD, or maybe if let's say you don't want to use CD, then you can use A1, B1, C1, A2, B2. It's up to you. Okay, but here in this example, I try to use AB, CD. Yeah? Okay, after you let U and V, then you have to add these two vectors together. Okay, but before that, okay, when you let U equal to ABS, you look at the condition here. B equal to 2A. So, we just rewrite back. Since you use AB, so the condition would be the same. Okay, and then for V, because you use CD, so this is B equal to 2A. So how do you get B is from the second component, 2A is from the first component. So D is equal to 2C, where your CD is an element in R. Now we add this together. How do you want to add this is by a normal addition vector, means that A plus C, B plus D. Okay? Okay, if let's say this is the vector, the first and the second component, so how would be your condition be look like? Okay, this one is B equal to 2A, D equal to 2C. So now your B has become B plus D, and then your A has become A plus C. Okay, and then you have A plus C, B plus D is an element of R. Okay, now you have to prove this. You have to prove this. Means that, okay, I use the first one first, yeah? To show you the first one first. Okay, B equal to 2 is, this one is left hand side, and then you have the right hand side. So this is your left hand side, B plus D, you have to prove until you get to A plus C, which is the right hand side. So the question is, how are you going to prove? So you have to prove by using this. How do you want to prove? You have to use this. Okay, means in the bracket there. Okay, now B. B is now 2A. 2A plus D is 2C. Then you have to figure out how can you show that this is equal to this. So for this, in this case, you just have to factorize A. So you get factorize 2. Okay, so you will get A plus C. So now it is already equal. So means your left hand side is equal to right hand side. If you want to check the second condition, A plus C, B plus D is equal to R, is an element of R. Okay, this one, because it's just an element, so actually you can just by looking at it, you know. If let's say A is R, B R, C is also R, D is a real number. So A plus C, B plus D is also a real number. So I'm not going to show that. Okay, remember that we have two conditions that we have to satisfy. So the second condition, we have to show that K, we have to find KU. Okay, so KU is AB. So this one you just expand. So you will get KA, KB. Okay, so what is the condition? B equal to 2A. Again, your B nouns become KB. And then 2A. A becomes KA. So again, you have to prove this. Okay, you have to prove this. So left hand side, which is KB. Now you have to prove until you get to KA, which is the right hand side. Again, how do you want to prove this? How to prove? Again, sorry, okay, how do you want to prove this? Go back to the U and V. So K is K, it's a scalar, B is 2A. Now, can you change, how do you get this to this? Just bring 2 outside and then your K, A. So you can just ignore the bracket because it's a multiply. So you will get 2K, A. So now your left hand side is already equal to right hand side. So your KU is also an element of S. This one I forgot to. Okay. Now, since KU is S, how do I want to highlight this? Okay, never mind. Okay, if let's say okay, KU is equal to S and U plus V is an element of S. So if let's say it satisfies both conditions, then go back to the question where the question is determine whether set S is a subset of S, R2. So S is a subspace of vector degree